So grade 11, so in this video we will be relating forces or the net force that is exerted on a system to its acceleration. Okay, we will be at the end of the video we will be explaining Newton's second law, which is the F naught equal to m times a, which is the acceleration. Now let's do this experiment to deduce this law. This person will be exerting a force on this cart, okay, that is initially at rest, it's not moving. I place this person here and he will be exerting a force to the left. He will be taking this cart to the left with a force of magnitude 15 Newton. And I will place a red person here that is taking this cart to the right with a force that is equal to 15 Newton. Let's see if what will happen to the cart, if it will move to the right or to the left, or it will not move at all. Let's see what happens. What do you think will happen? Let's see. Okay, so when we played the video, the cart didn't move at all. Why is that? Why do you think this happened? Because the force that is exerted by this person is equal and opposite to the force exerted by this person. So these two forces, the sum of these two forces, let's see, is equal to 0. Okay, so that's why the car didn't move at all. The sum of the forces is equal to 0. It didn't move. Okay, now let's try placing this red guy here on this side, and let's see what happens here. Look, the sum of the forces that are directed to the right are now equal to 150 Newton. However, this person is still exerting a force that is 15 Newton. What do you think? What will happen? Will this object accelerate or change speed to the left, to the right, or to the left? What do you think? Of course, let's see. Of course, it will move to the right. Let's see. Okay, so it moved to the right. Why? Because of some of the forces that are acting on this cart is equal to 100 Newton, and it is directed to the right. So the forces that are acting on the system are taking it to the right. That's why it's moved to the right, okay? That's why it's accelerated in the right direction. So here we can say that actually the external forces acting on a system is the reason behind its acceleration. If the sum of forces is different, and like in this case, it's different than 0, the part will accelerate. It will cause the system to accelerate. Okay, what do you mean by accelerate? It will change speed with time. The speed of the system will change, okay, with time. So this is lets us arrive at Newton's second law, which tells us that the acceleration of an object is proportional to the net forces acting on the object. So if there is a net force that is acting on an object, what do you mean by net force? The sum of all the forces, okay, that are acting on the system. If it's different than 0, if it has a certain value, the object will certainly move and it will accelerate. The speed of the object will change with time. Okay, so what Newton's second law states it tells us that F net is proportional, or it's equal to m. What is m? It's the mass of the system. Okay, that the forces are being exerted on, which in this case, in the example that I showed you, it was the cart. Okay, So the mass of the cart, and A is for acceleration. Okay, this is Newton's second law.